All right. Potentially the last, probably the last meet session for COMP-111. What would you guys like to talk about tonight? Okay, so get scorecard, lab 5. All right, let me pull that up here. I think I just opened up the wrong one. Hang on a second. This guy. Absolutely not. You know what? It's your dime, so get the most out of your tuition dollars. Okay, get scorecard. Okay, so we're retrieving a scorecard for a particular, at a particular position. Okay, now we've got a couple, okay, well, I'll take a look at that. Status sort versus par 2. Okay, so get scorecard, we're retrieving a scorecard at a particular position. Okay, so we know what the position is because it's right here. Do we have a separate get scorecard? No. And this is the one, right? Get scorecard. Okay. So we're retrieving a scorecard at a particular position, and we're told what the position is. So remember that your board is an array of scorecard objects. So your this.board instance variable is an array of scorecard objects. Okay. So, or I'm sorry, an array list. So this.board is an array list of scorecard objects. Sorry, I'm just getting, oh, that's not the right language. Language, J, Java. Okay. So we have this.board, board, which is an array list. Okay. We know what the element position is because that's our explicit parameter and it's contained in position. And we know we need to validate it. So just because it's an array list doesn't mean that this is not going to be valid, right? So, and we know that we're supposed to return a scorecard object, but if null, if there's not one. So here's how we can validate it. If it's less than 0, in an array list, the boundaries are still the same, right? The lower boundary is still 0. The upper boundary is going to be the size in an array list. So you don't have a fixed length going on here. We have, you know, it's variable. It can continue to grow or shrink. So the size is going to be your upper boundary. So if it's less than 0 or greater than the size, not greater than or equal to, greater than the size. All right, because if your size, and so let's say our size is 10, then that would mean we have elements in position. So elements 0 through 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and that would be our 10 elements. So if our position is less than 0 or the position is greater than the size, then we know we're outside of the boundary of our array list. So we're just going to go ahead and return null. Okay, we don't really need an else statement here because if it falls in this category, we just return null and we're out of here. All right, so then how do we actually get this? Well, we know what our element position is. And in an array list, we have different methods, right? We have a .add method. We have a .set, which is position, and then the value here. We have a .get, which is your position. Okay, so the add would just be the value here. And then we have a .remove, which would be the position. Okay, and the .size, which just returns to you however many elements are inside of the array list. So to get our actual scorecard at that particular position, we just call the array list get, this.board.get, and we give it the position. Okay, so this is a scored card object that's stored, so that's the data type is a scorecard object, right? So we're creating a temporary variable called found card. We're retrieving this scorecard from the array list at the position. So that's step one. We've got that. So that's awesome. But we don't want to just return, like we could, theoretically, right here, we could just say return found card. But it doesn't, but that's not completed. It says return a copy. We have to make a copy of the scorecard object. And the whole reason for that is if we just return our scorecard object, then we have so that would mean that, so like in this demo, I don't know if they called a get scorecard. It doesn't look like they called a get. But if they did call the get inside of this demo, they would have a pointer to our scorecard object in here. And we would have a pointer in here, two variables pointing to the same object in memory. And if you have two different variables pointing to the exact same object in memory, both places could make changes to that object. And then it can screw everything up. So we don't want anybody else to have access to it's the same as defining our instance variables as public, because we've just given them access to our data, and we don't want to do that. So instead, we're going to return a copy. We're going to make a copy. So the first thing we need to know is we need a copy of this scorecard itself. So we need to know what our what our constructor is for the scorecard object. So let me get out here so I can get to labs. So if we come into our lab 5, we have the plus libs here. In the plus libs, we have a doc folder, and in here we have our scorecard HTML. So constructor, we only have one scorecard constructor here. Let me make this bigger so maybe you guys can see it. We have one constructor. It takes in a string value, which is the name of the player. And if we click on that, our constructor here, it's just the name of the player. So we can create a scorecard object giving it the name of the player as soon as I find it, which is what we've done here. So another scorecard object called temp equals a brand new scorecard. We're calling the constructor, so equals new scorecard, and then we need to give it the name. So that's what we're doing. In this found card, we have a scorecard object, so what's the method to get the name? The method to get the name is called getName. It returns a string value for us, so it returns data type of string. GetName, so we will call the getName, where am I at? GetName method to return it and do that. So it might actually be easier to do string temp name equals found card.getName. Okay, and then inside of here we can call it with our temp name. They both do exactly the same thing, but sometimes it's easier to look at that way. So we've created our scorecard object, which is awesome, but the scorecard contains more than just the name, right? The scorecard object contains all the scores that the player played on all the holes. So we've got this scorecard now, but it's empty. We haven't copied over the scores. And so we need to know, so this will tell us what score the player got on hole. So we're back to our scorecard, so we can definitely do a get score on hole. And we know we have a record score, which is the hole number and the stroke. So the get score on hole wants our hole number. But we need to know how many holes the player has played. And so if we come back up here, let's take a look. We've got compute strokes, count category, get holes played. So we can call on our scorecard to find out how many holes did the player play. So let's do that. So we can do an integer holes played equals found card .get holes played. So now we know how many holes this player played. All right. And then we need to loop through each one of these holes. We're going to need to create a loop, or because we have these holes played, and it could be up to 18, so we don't want to write 18 individual statements, right? So we're going to do a loop here for integer. Well, I'm just going to kind of give this to you in pseudocode so you guys can write out the actual code. So we're going to loop for holes played times, right? So, you can do I equals 0, I is less than holes played. That's how many times we're going to loop. Then each time in this loop, we need to get how many strokes it took them to play in the found card, and we need to record that on our new temp card. So we're inside of here, and let's say we're going I equals 0. I is 0, but what whole number is that? So if your I is 0, that equates what whole number? 1. Okay, so we can get score on whole, giving it the whole number. So our found card, so we can say, integer strokes equals found card dot get score on whole, giving it your whole number here, right? Not the number of holes played, but this actual whole number that we're on, which if I equals 0, then your whole number is going to be it's going to be 1, but how would we get that mathematically? If all we have is a variable I, and we know that the first time I is 0, and the second time I is 1, and the third time I is 2, and so on, mathematically our whole number equals I minus 1. So if we start out with I is 0, then our first whole number is negative 1. Is it just I? So if our value of I the first time is 0, did they play whole number 0? Well, I would equal 1, but how do we get I to equal 1? So if our loop is this for integer I equals 0, I is less than the holes played, I plus plus. Okay, so if you did integer I equals 1, what did you make your condition then? Less than or equal to holes played. So you can definitely go that way. Or you could, if you went with I equals 0 and it's less than the holes played, then the hole that you played here would always be I plus 1, right? So if it's 0 the first time, then I plus 1 is 1. If it's 1, then I plus 1 is 2, and so on. However you want to do that, you got to get your hole. So you'll get your strokes. And then on your temp guy, your temp card, you need to call the next method to record that score. And we've got that here, record score accepts 2 explicit parameters. One's the whole number and one's the strokes. So now on your next one, you need to actually add it. So you'll call your record score, whatever the name of that method is, giving it the whole number and the strokes that you just retrieved. Okay, so you find the one you're looking at the position, get the name of that guy, get the holes played. So that's the information you need to, it's basic information that's not going to change, right? Every single time through, the whole number of holes that they played is still the same, the name is still the same, and so on. You build your new version of the temp card, giving it the same name as the original one. So we give it the same name. And then we're going to loop through now. So we've got a scorecard object, but it doesn't contain any information about what the player did on the golf course. And that's what we need to add. So you loop through for each one of the holes that they've played, and on each hole you retrieve the score from your original guy, and you add that score to your new temporary guy. And then when you're all said and done, you return your temp. Okay, questions on that one? Okay. It should be the exact same whole number that you specified here. Whatever you put here should be the same one you put here. Because if this is what they played on hole 1 here, then that's the score you want to add for hole 1 down here. Yeah, you don't want to do you don't want to do 1 is greater than or equal. So that should be I is greater. You don't want greater than or equal to the holes played, because how do you ever get less than 1? You would end up with an infinite loop, right? Well, Matthew, let me ask you this. If you have played, so let's say we have an 18-hole golf course, and you've played 12 holes. What's the first hole that you played? What's the second hole that you played? And the third hole that you played? Right. So you know how many holes you've played, right? Because you just got this value. You know how many holes you've played. And it's stored in this variable right here. So it doesn't matter what this is. You know this is how many holes I've played. So I need to start from 1 and work my way up to this number right here. Oh, are you asking here? You just got a scorecard right there. Okay, so let's work from the test case, and maybe the test case will help you get it better. Okay, so, and Liz had a question on the test case anyway, so let's move over to the test case. So if we're in the test case for this get score on hole, we know we've got a bunch of samples up here, right? We've got 6 holes on this particular golf course, okay? We've created a board 2 called the Moorfield Invitational, and then there's a bunch of different golfers that we've added here. So we don't even have to use that golfer there. So let's call the get position here. Sort versus par, record score, get scorecard. So let's get rid of all this stuff. Okay, so we've got board 2. So let's say board 2 dot add golfer Compston. I am now going to be a golfer on this golf course. And the very first hole is the one that gets recorded when you do this. When you add the golfer you're in, I scored a 5 on this very first hole. Okay, so then I'm going to record some additional scores out here, and the method to record a score, add a golfer, find a golfer, get number of golfers, set the tourney, somewhere in here is remove golfer, get scorecard, record score, golfer for score. So I give it the name, the whole number, and the score. Okay. So then I'll do board 2 dot record golfer score, and I give it the name of the golfer, so still Compton. This will be hole number 2 because they have to be recorded in order. If they're not recorded in order, the score doesn't get recorded. So this one I did a 3 on, and then I'm going to just add 2 more holes to this. So this will be hole 3 and then hole 4, and I'm just going to go a 4 and a 5. Okay, so I've added this golfer to my board 2 scoreboard. Okay, and actually, yeah. And so there's already some golfers that have been added to the board 2. There's Nicholas, who was the first golfer added, so she should be in position 0. There's Woods, which was the second golfer. He should be in position 1. Sorenstam should be in position 2. Ochoa should be in position 3. Lopez should be in position 4. And Watson should be in position 5. So if I'm adding myself to this, I am in position 6. Okay, where did I go? Okay. So if I am going to test this, I would want to do a scorecard equals board 2 dot get golf, what is it called? Get scorecard and that would be position, did I say 6 or is it 5? Now I can't remember. I think it's element position 5. I'm the 6th golfer, right? But no, I'm the 7th golfer. I'm in element position 6. Okay, so I'm giving it position, element position 6, which should be the last one that was added, right? And then if I want to, so that, oh, I needed to give this a name, temp card. So it should return this into my temp card here. I call this and it should return to me a scorecard object for position 6, which should contain all of these values right here. So I can definitely test this, but I'm going to have to call scorecard methods to do it. So I'm going to do an assert equals. The name is going to be Compton. Temp card dot, and then I need to go out here to my get name, the name of the player. Okay, because I would expect if I created this scorecard object with a golfer name of Compton, then that's going to be the name that it's going to have, right? And then I'm going to do an assert equals, and I want to check hole number 1 to make sure it has a score of 5. So get score on hole, I'm going to pass it my hole number, and it should return me a value of 5. So 5 temp card dot get score on hole 1. And then likewise hole 2, hole 3, and hole 4. So it would be 3, 4, 5, and this is hole 2, 3, and 4. Okay, so if I were copying this, if I originally had, oh, yeah, so this should return me an exact copy. They're not equal, so temp card would not be equal to the original one that was out there, but it should return me an exact copy that contains all the same information that we had here. So the first hole had a value of 5, the second 3, the third 4, and the fourth 5. And so you can see that's what I have here, a score of 5, of 3, of 4, and 5. So this stuff is all pre-built out there. You don't know what the values are. You're working. See, I think that's some of the problem is people are like, but what exactly is the data? It doesn't matter what the data is. You know, you're working with what, with potentials of 1 record or 100 records. It doesn't matter. The logic is exactly the same, right? So it doesn't matter that I've played 4 holes and somebody else has played 2 holes and somebody else has played maybe all 6 holes. The logic for this is going to be exactly the same. And so the logic is first make sure the position you're checking is valid. Is this a valid position? Does position 6 actually, is there actually a golfer in that element position? So first validate, does that position valid? Then retrieve it. Get the element that is at that particular position. If it is valid, get that element. And the element, it stores scorecard objects. So store that object somewhere so that you can manipulate it. You know you have a scorecard object, and you know that the only constructor available to you is this one right here that takes in the name of a player. So you need to get the name of the player, and to do that you look at your scorecard Java docs, and the only one, if we're looking compute strokes, compute versus par, count the category, get the whole split, get the name. That's the only one we have. So we can call that one, if I can get back to where I need to be, we get the name by calling that on this one that we just retrieved from the array. So this is all what we have, okay? The other thing we need to know is how many holes did this player play? We don't know how many, like I don't know they actually played 4 holes. I just know that the number of holes they have played, I can retrieve that by calling this method. And so this value here is going to tell me how many holes the player played. And it doesn't matter if that value is 0, then they didn't play any holes at all. If it's 1, they played 1 hole. If that value is 4, they played 4 holes. It doesn't matter. All I know is that that's how many holes they've played, and based upon that number, I need to retrieve every single hole that they've played. And I know that my first hole will always be hole 1, and my last hole will be this value right here. So if it's 6, I need to get the values for holes 1, 2, 3, 4, 5, and 6. If it's 4, I need to get the values 1, 2, 3, and 4. If it's 2, I need to get the values for 1 and 2. It doesn't matter what that value is. The logic is always the same. So I know how many holes have been played. It's right there because I called the get holes played method on this scorecard object that I just got out of the array list. Okay. So now I can create my new temporary, passing it the name, because I have to. That's the only constructor I've got. I've only got one constructor, and it takes in a string value, which is the name of the player. Okay. Then now I need to loop through each one of the holes. Okay. I need to loop through each one of those holes. Now I could have made this really super tedious, right? I could have said if holes played equals 0, then just go ahead and return my temp. I don't have to record, you know, it's temp, T-E-M-P. I don't have to record any scores, right? And then I could have said if holes played equals 1, then my strokes equals found card.get score on hole 1, right? And then temp.record score 1 strokes. And then I could have done that, right? But then for holes played equals 2, I would have to, if it's equal to 2, I'd have to do it for hole 1, and then I'd have to repeat these statements here for 2. And then for 3, I'd have to do all that same stuff, but for 3. And then for 4, I'd have to do all that. And I'd have to account for, I don't know how big this golf course is. I mean, we'd like to think that 18 holes is the maximum. I have to have 18 of these if statements, which is a lot of statements to be had. So rather, and I'm doing the same thing over and over again, right? So rather than having all these if statements in here trying to account for every possibility for holes played, I'm just going to loop through here. So I can loop starting with hole number 1. No. What did I use position for? Right here. What's the position? The position is your golfer. So think of a physical scoreboard. Let me try. Let me go visual on you. Maybe this will help make it make more sense. Maybe not, but we'll give it a chance. Paint. Nope, it's all good. I can understand that you are not a golf fan. I'm not going to say that I am either, but I'm going to tell you I don't really like baseball. Okay, so we have a scoreboard, right? And on the scoreboard, we have a player. My writing is going to be bad. And then we have a bunch of scores over here, right? And then we have player number 2. And they have a bunch of scores over here. And then we have player number 3. And they also have a bunch of players over here. This whole thing right here is your array list. Okay? Each one of these guys in here is a scorecard. Okay? Each one of these guys in here is your scorecard. So when I give you a position, I'm saying, hey, right there, I want you to give me the scorecard for this player right here. And I give you position 0, 1, 2, 3, 4. Okay? Give me this guy's scorecard, number 4 on my board. So position is the location of the scorecard on the scoreboard. All right? So the scorecard, so it's almost like I'm trying to think. If we bring up our Excel, I'm not sure if Excel will make it any easier or not. So we have a scoreboard, right? And each scoreboard, we're going to have a player and then their scores, right? And then their scores here. So we might have Compton and Jones and Smith and somebody else, Ochoa, okay? So we would number these. They're going to be element position 0, 1, 2, 3, 4, 5, 6, and 7, and so on, right? So if I told you to give me, and then included in here is all of their scores on the different holes. So this would be hole number 1 and hole number 2 and so on across here. So if I tell you to give me position 2, that tells me I want you to grab the golfer that's located in position 2 on the scoreboard. And that would be Smith, and along with Smith comes all of his scores as a scorecard. So the scorecard has the name of the player, but then it has an array of holes. So then you would have your holes here, you know, whatever they scored, 5, 4, 6, 4, 3, you know, whatever. Okay, so when you say get what's at position 2, you're saying grab the scorecard for that player that's at position 2 on the scoreboard. Is this helping at all? I know you don't like golf, but is it helping you at all? Okay, so once you've got the scorecard, you set it, you don't need position anymore. Position is done. All it did was tell you which scorecard you needed to retrieve. So you've got the scorecard. Now you need to work through the holes. Okay, so you're working through the holes, and the first hole is always 1. And the second hole is always 2. And the third hole is always 3. But you can only retrieve the holes that the golfer actually played. Okay? And to know those, you've got your scorecard. It's here in your found card, right? So call and get your number of holes played. And you know the first hole is always going to be 1. And you know the second hole is always going to be 2. And you also know the maximum number of holes they played. So you want to stop As soon as once you get greater than that number, the whole number is always I. Exactly. Assuming that you start with 1. Assuming you do this less than or equal to wholes played. If this is your if statement, I plus plus, not plus equals, then your whole number is always I. Yep. Liz, working through the test case, did that help you out any with your test case issues that you were running into? Have you posted it up to WebCat or? I mean, I know WebCat will fail it because your test case isn't passing, but I can at least take a look at your code there, and I can see the output, to see why it's failing. Or you can send it. You can send your information to me, and I can take a look as well. Oh, maybe that's it. Good catch, Dylan. So Liz, notice on here I'm calling get score on whole because my assert equals are all lowercase e's and they should all be uppercase e's. So I'm calling get score on whole. Did you call get score on whole or get score card? You only call the get score card one time to retrieve it, but then you're going to check the card to make sure that the card contains the values you want. I think that does have to be greater than or equal to now that I'm thinking about it. Because it always needs to be less than the size, so it should be greater than or equal to there. All right, so this looks like a mess just because of the way it is, but let's see if we can make it a little bit more readable. Okay. So if it's less than 0 or greater than or equal to the size, out. Okay. Because the size would be like 10, and so it should be 0 through 9. So if it's greater than or equal to the size, out. So make that greater than or equal to not great. Okay, you got this found card. You created your temp, retrieving the name. Okay. And you called this, so this statement here, because you have this statement there, you don't really need this statement here. But it doesn't hurt anything. You get the wholes played. For I equals 1, okay, you've got that. So this looks good. I is less than or equal to the wholes played. Strokes, so think about this for a minute. The first time through, I is 1. So that's whole number 1, right? But you're getting the score for I plus 1. So that means even though I is 1, you're saying I plus 1, and what would be 1 plus 1 is 2. So even though I is equal to a 1, you're saying getting the score on whole 2. Is that what you wanted to do? Yep, give that a try. See if that makes it any better. Come on up. All right, so Liz, did you see that comment Dylan had on your assert equal statement? Was that your issue? Oh, you have get score on whole. So what is your whole, like all of your test statements? And I haven't forgotten, Dylan, you want to do the sort versus par. Was it a specific question you had on the sort versus par? If all right. So Liz, are you sticking your stuff out? Can you post your test cases out here, or and Dylan, go ahead and type your questions and we'll. Well, when you click on it, what does it say? Expected this, but what did you get? Expected negative 999, but got what? So you expected 5, but it was negative 999. So the question is, so you change this to be I, right? Right here. No, that should not be it. Positions less than 0, or it's greater than or equal to the board size. Oh, so that might be the problem too, record golfer score. Is your test case for record golfer score working? Work on your record golfer score, which should be really straightforward. You've got the name, you've got the hole, you've got the score. So you just need to get the card and then record the score. Because if we go out to record score, it is record score with the whole number and the strokes, but for that specific card. You know how to get the card because you've got that right up here. Do we have that? Find golfer. You know the name, right? If we're down here and record score, we know the name right there. So record score, you can do, you know, this dot, whatever, you know, scorecard, or it's in your board, whatever it is called. Well, we've got the name right there, so you can find the golfer with the name. Okay, so this is going to be your scorecard person. Temp card equals find golfer with this particular name, right? Oh no, that's not what you want for your record score. Okay, so let's take a look at that. Okay, so see what you're creating a brand new scorecard object, brand new. You're recording the score for that brand new scorecard object, and then you're trying to add it to the array list. So let's think about this. The very first time you add someone, so let's say we add, geez, I cannot remember his name, Nicholas, to the scoreboard. You're adding it with whole number 1, right? So we already have a scorecard. So we've got our scoreboard out here, our scoreboard. And we've got Nicholas on there. I should have put, we got Jones on there because I can spell Jones easier. And we've recorded his score for hole 1. He got like a 5. Okay, so we've got that on there. Now if you do this, you are creating a brand new scoreboard object. They also have a name of Jones. We have 2 players with the name of Jones, right? And then you record the score. So you created this brand new scoreboard object with this name of Jones. You're recording the score, but this is now like hole number 2, right? 2 has a hole of 5, but you can't do that because this is a brand new scoreboard object. It's not the same one that we have up here because you created a brand new one, right? So this guy, you're trying to record the score for hole 2, but you're not allowed to do that because you have to record them in order. And he doesn't have a score for hole 1 because this guy is not the same. They just happen to have the same last name. So the score doesn't even get recorded. You have Jones out here now, but no score. And then you add him. So now you've got this Jones out there in your board. Now you've got a second Jones with no score at all because you couldn't add the score because that was hole number 2, and you have to start with hole number 1. So when you're recording a score, when you're doing the record golfer score, you have to get the golfer that already exists out there so that we're adding to this record, not creating a whole brand new record. Okay? And you've got this method called find golfer that's going to find you the one that exists out there. So you're going to call this find golfer, and it's a scorecard object is what it's going to return to you. All right, find golfer with the name. Find golfer with the name. Oh, that's add golfer. Find golfer. Oh, it just returns you the position. I'm sorry, it returns you the position of your golfer. So down here, it's returning us an integer position. Integer position equals find golfer with the name. So now we know what board position it is out there, right? So this dot board dot get subposition is our golfer on the board. All right, you guys sticking with me so far? So this is your golfer on the board. So now we have our scorecard. This dot board dot get position is our scorecard with the golfer of that particular name. So now we can call the method record score, giving it the whole number and the number of strokes. And we know that because that is right there, whole and score, dot record score, not spelled correctly, but whole and score. Okay, not spelled correctly, pretty ugly looking, but see what we need to do? We know the name of our golfer. We have to find the card that already exists out there. So you're going to call your find golfer to get that person, passing it the name that you know. That's going to give you the position. Now that you know the position, you can go out to the board and get that scorecard element at that position. And then you can call the record score method, giving it the whole and the score that you already have. Awesome. Liz, how about you? Yay. All right. Well, Dylan had a question here. Did you type your questions up there, Dylan, or? You have been awesome at helping out with this. Okay, so what you have to think about, it all depends upon um, on how your references look. Okay, so let me copy that. Okay, so we have temp equals get what's at position J, and then set J equal to what's at position J minus 1, and then set J minus 1 equal to temp. So theoretically, after this statement gets done executing right here, the scorecard at position J and the scorecard at position J minus 1 are both pointing to the same object, right? Now when we do this statement, J plus 1 will no longer be pointing to the position at J, but we'll have temp and J minus 1 now both pointing to the same object in memory. Okay? So yes, currently we both have temp and J minus 1, what's at element position J minus 1, pointing to the same position in memory. Oh, I see where you're going. So then the next time through when we change temp, doesn't it change the element position J minus 1? Is that where you're headed with this? Oh, no. No, because let's give these names and it'll be easier, okay? So board subposition J, let's say that equals Jones, okay? All right, and then board sub J minus 1, that equals Smith, okay? So we come into our swap and we immediately set temp equal to Jones. Okay, so now board sub J equals Jones because it's an element position we're working at here. And board and temp is equal to Jones. Then we come in and we say, you know what, I don't want element position, whatever J is, to be equal to Jones anymore. I now want it to be equal to Smith. So we set board sub J equal to Smith. Well, my parentheses are not. Sub J equal to Smith. But temp is still pointing to Jones in memory, right? Yeah, I think you got it. But then what happens, well, what we've got is we have object references, but then we've got an array list as well. So the object reference gets overwritten in the array list. Yeah. Cool. Okay, so what was your question on the final? Because everybody may benefit from that as well. Sure. It doesn't have to be like super built out, because there'd be a ton of different data that you might need depending upon your scenario, and you'd probably keep adding to it as well. Um, but if you're thinking about like dependencies and things like that, a customer is a customer, right? So a customer doesn't need a pet to be a customer. Now, we'd like to think that a customer has a pet if they're coming to a veterinary office, but their pet may not be being seen. Maybe they're just stopping by to pick up dog food for their neighbor. So they're not really a customer, you know what I mean? So a customer can stand by themselves. So we've got a customer and they can stand by. No cohesion. They aren't dependent on anything. Okay. And things you might need for a customer might be what? Like a name and an address, a phone, that sort of thing. Okay. Customer should stand by itself. We also have a pet, right? Definitely a pet. And that can stand by itself too. A pet doesn't need a customer, doesn't necessarily, it could be a pet that's up for adoption. So it doesn't currently have an owner, right? So a pet also can stand by itself. And so again, you might need to know the name of the pet, maybe the birth date, the date of birth, what type of pet it is, you know, breed, that sort of thing. Is it a cat? Is it a dog? Is it whatever? But that could stand by itself as well. You know, we don't need, it doesn't need anything else to be a pet. Okay. But then you get into the other things where you have a veterinary office. And so an office is going to consist of customers and pets. And we have appointments. Yeah. Yeah, it's kind of like you work up the other way. And so an appointment would involve a customer and a pet together, right? Um, you know, assuming that there is a customer kind of going, and you would definitely have an invoice should stand by, you know, an appointment should stand by itself. Think nouns. So appointment is going to be by itself, and that is going to have a customer and a pet. And then you have an invoice is also a noun, and that is going to be based off of an appointment. We're not going to get into the whole details where they could be coming in to buy, you know, food and not have an appointment. We'll just assume that they have an appointment. So an appointment, which takes it to a customer and to a pet, and then you have your whole veterinary office that sits over the top of all this stuff. But yeah, you're kind of looking, yeah, you kind of want to go. So technically, the stuff in an invoice is dependent on an appointment, which is dependent on a customer or a pet, and then these two guys can stand by themselves. If you have your customer, you'd have to have an array of pets inside your customer class, because a customer can have more than one pet, right? But then think about if we go to the, I'm sorry, I messed up my cohesion and my coupling. Think if we go to abstraction or cohesion, where we're trying to keep something to a single concept, have we now made our customer too big? You know, it's now more than one concept. It's a customer that has pets and has appointments. Typically what you're going to have is you're going to have a class that joins these together. So you might have an ownership class, and in this you would have a customer and pets, and that would tie them all together. So you would definitely leave your customer separate and your pets separate, and then create some sort of an ownership class that ties both your customer to your pets. So what you end up with by putting all that stuff in one place is one great big class. So not necessarily wrong, but typically it works the other way. Well, and that would be great for the invoice to do invoice with service and line items. You know, it can, sometimes I get confused thinking about it. But what you have to think about is, could you have a customer that has never had an appointment? And you could, right? Because the customer may just be coming to buy supplies from the veterinary office. And could you use your customer in other ways? So should it have all that stuff tied into it, or do we want to keep it, unique kind of a thing, and then tie it together in a different program? It is, you'll get better with practice for sure. Yeah, it's one of those things. It actually comes down to when you're dealing with like databases and you get into the whole third normalized form and stuff, it just gets better. You get better with practice on it. But you're just going to draw an arrow from one class to the next. So in this case, we would draw an arrow from our invoice to our appointment. So it's a dotted arrow, and the arrow points at the appointment because it's going invoice is dependent upon appointment. So you would go from here. And then from your appointment, you'll draw an arrow to the customer and an arrow to the pet. So from the appointment to the customer, from the pet or appointment to the pet. And then there's no arrow between the customer and the pet. So if we were to go back to our Blue Jay here, assuming this is like our invoice, it would draw down to our appointment. And then I don't have a good example for the other ones, but if you had appointment, it would draw down to customer and down to pet. Well, that's where an ownership table could come into play. And you can create an ownership table that shows this customer or this pet goes with this customer kind of a thing. Sure, go ahead and post them out there. And while you're doing that, so Liz, did you have another question for Lab 5? Or are you struggling with the sort as Matthew has kind of indicated? You can go ahead and type out your questions, Dylan, too. Dylan, yes. A parameter variable is considered a local variable to the method. So it comes into existence at the point that the method begins and ceases to exist when it finishes. Right. So somewhere in here I have, here's array lists, okay? So you're dealing with an array list when you're sorting here. So you're going to have to incorporate kind of this one and that one, making it work. You know, so when you're doing your swap, you're swapping in this way, but we're not doing integer data, obviously. You're doing scorecard data. Okay, so Liz, then the question is, where does the -1 come from in your code? -1, so the only thing that actually contains the value of -1 would be your under par value, right? Which test case was it that you're getting that? Oh, not found is equal to -1? Yep, not found is equal to -1. Yeah, you can change it to -1. Technically, you are supposed to, yeah, take a look at your code and see if it's returning not found or if it's returning -1 in your code itself. You know, wherever it's supposed to return a not found. So here is return -1 if the player is not present. Return your constant not found. Make sure it's returning not found here, which it should be. I think that was given for you. Okay, so Matthew, on this one, the bubble sort, you kind of got a combo of these two guys that you're going to be using here, right? Except for your object data is going to be a scorecard, not integer data, right? So you need to get the value, you need to drill down to actually get to the value that you're wanting to sort on. And for this, we are sorting on the versus par value for the player. So we have to go to our scorecard, and it's compute versus par through whatever whole num that you give it. So you need to know how many holes did the player play, right? So you've got to take that scorecard that you've got there at position I and position I plus 1, or whether you're counting up or you're counting down. If you're doing the bubble sort, you're going up. So I and I plus 1, you first need to get that value. Okay, so scorecard 1 equals get what's at I, and then scorecard 2 is get what's at I plus 1, right? Which is exactly what we've got in the PowerPoint right here. get the value at I, get the value at I plus 1. But you got to use array list methods, not array direct access. So here's your array list methods is the dot get. Okay, so now we've got our two scoreboards, but that's not what you're sorting on. You're sorting on the versus par value. So then you got to call that compute versus par, but you're passing it the through whole number. So you don't want to say compute it for whole 1. You want to know for the player as a whole, what was their whole thing? Like what have they scored up to this point? So you need to figure out how many holes did that player play. So we've got the first one at position I, so figure out how many holes they played. This is a scorecard object. You go out to your Java docs, get holes played. Tells you how many holes that particular player has played. Okay, call the get holes played. Now you need to compute the versus par, which again, compute versus par is going to tell you through whatever hole you specify. So you know how many holes they played. You just figured that out. You just called the get holes played. So give them that whole number. Compute versus par through whatever that whole number is. And that gives you the value, an integer value for player, for whoever the player is at position I. Now you need to do all those same steps for the player at position I plus 1. So you've got this one. You need to call the holes played for player 2 for the second player, and you need to get the score of compute versus par for the second player. Once you have that value, then down here, you just follow this along. I actually followed along over here, right? You're just going to compare, instead of this, you're going to compare par 1 to par 2, compare those two values. And if one's greater than the other, then you're going to set your did swap, and then you're going to flip your values here using the array list, not the array, and it's a scorecard object, not an integer object. Okay? Do you see what we did there, Matthew? Dylan, did you have your other questions? I don't remember what the... Yep, Saturday. Oh. Oh, and trying to determine what class and how they depend upon each other. No, we did not. But if we take our golf thing for an example, right? We have a player. That could be a player object that stands by itself. A player doesn't need a golf course or even to be playing in a current tournament to be a player, right? So if you take that, you've got your player, and he's not dependent on anything. Okay? And then we incorporated a player into a scorecard because a scorecard does need a player in order to record scores on it. So we've got our player that stands all by itself, and then we have a scorecard that is associated with a player. And then a scoreboard needs to have the scorecards on it to become to be useful to contain scores. So it's kind of like you go up that level. So we start at the bottom with our customer and our pet, in this case, both of them start at the bottom. And then we move up to appointments because that's when we actually need to incorporate them. and those incorporate the other classes. And then we move up to an invoice, which incorporates your appointment. Oh yeah, you would definitely do all that stuff, but that's way beyond the scope of what we're doing here. Yes. So you would definitely want to be able to search by customer name, and you'd want to, what appointments have they had, what history have they had, but you would definitely keep them separate because they could have had no appointments at all, or, so. I actually spent a lot of time at the vet this past week, so maybe it's appropriate that that's on our last homework assignment. Yeah. Yeah. Yes, it is. Yeah, I know we've gone way over, guys, so I'm sure you're probably invoice. Invoice depends on the appointment, and the appointment depends upon the customer and the pet, because the combination of a customer and a pet makes the appointment. All right, so what I'm going to do is, I mean, we've gone way over tonight, and I appreciate you guys being interested and wanting to stick around. So what I do want to tell you is this: if you get to the point where um, it's Saturday and you just need to submit the lab and you're done, but your test cases are still not passing, WebCat won't give you any points for a failed test case, right? So here's what I want you to do on the test case. I want you to, if your test case just won't pass, I mean, you'll still lose points, but at least you get a score. I want you to come in here, I want you to comment all these out, and then just put like a return. I think it'll let you do that. Assert true is true. It will allow your test case to pass. You still won't get points for it. WebCat will still take points off, but it will allow your test case to pass so that WebCat can at least give you a score. Yep, that's exactly what you'll do. Like I said, you'll still lose points, so best, of course, is to try to figure it out and get it working. But if it comes down to WebCat is not giving me any score and I just need to make my test case pass, you can put in assert true, true, and it'll force it to pass. Like I said, you'll lose points, but you'll at least get a score. Yeah. Yeah, exactly. On the sort versus par, I mean, you need to retrieve the information. And I did this in a whole bunch of statements. You could actually nest this all into one great big huge statement, if you wanted to. So it could become this great big huge statement. So it would look something like integer par1 equals this dot board dot get sub I dot compute versus par. No, wait. Yeah. Compute versus par on this dot board dot get sub I dot get holes played. Okay, so if you wanted to do this great big huge enormous statement where you're saying compute the versus par for this particular board at position I by using this holes played for this position hole, then you could do this, but then this will be longer than 80 characters, so you're going to have to break it like right there. Or you can do this, which is much more readable, and go from there, right? And you could even, if you really wanted to get fancy, you could say if this is less than, and then you can, not even have to put them into temporary characters, but yes. All right. All right, we're going to call it a night. If you guys run into further questions with your labs, post them out. Post your lab to WebCat and then send me an email and say, hey, this is where I'm having a problem. Can you take a look? And then at least on WebCat, I can then tell you this is what the instructor output is. I can see both your regular code and your test cases at the same time. And then that way I can point you to a good direction. And thank you so much for sticking around, guys. And yeah, shoot me emails, shoot me out to Piazza, whichever way, and I'll take a look at it. All right. Have a great night, everyone, and good luck on that final.